This chapter, it's very straightforward. There's like, let's say four equations that you learn throughout the chapter, and the concept is just patterns, which are nothing really too new. So this should be just a nice, simple, straightforward one. Doesn't necessarily make it easy, but what to study is very obvious. Okay. But before we even talk about the actual equations, we need to talk about the vocabulary of it. So let's talk about sequence and series. Today we'll focus on sequences. So what exactly is a sequence? A sequence is just a pattern of numbers where you start counting from 1 through 10 or whatever integer. So I have an example here of a sequence. So the sequence is 4, 7, 10, 13, 16, 19, 22. Anybody could speak up. What's the pattern that's going on here?
2
Plus 3.
3. So you're adding 3 each time. Now, when I say 4, that represents what we call A sub 1, or this is the first step, or your first part of the sequence. So when I say A of 1, I want the first step, which happens to be 4 here. If I say A of 2, I get the second step. If I say A to 3, I get the third step. If I say A to 7, I get the 7th step. So this little number here represents what number step you're on and what number step I want, or what number step you're looking at. Doesn't, depending on how you say it. Okay. And in here, someone already said it. Wait a second, this is just you're just adding 3 each time. So we know it's just plus 3 each time to find a pattern. So can somebody tell me what A8, A9, and A10 will be? What will be the next 3 terms here?
Is A10 2?
A10 2. No. You have to follow the pattern. So if each time I plus 3, every next step, I should be doing the same thing. Haley, what's A8 in this one? Go ahead.
5.
25. Ella, what's A9?
28.
28. Mariah, what's A10?
I don't know. I'm doing plus 3 on that.
Yes, you're doing plus 3 on that.
31, 30.
31. Good. Absolutely. 31. Yeah. So that's the basics of a sequence. It's literally just a pattern of numbers where we count, starting at this is step 1, this is step 2, this is step 3. You always start on step 1 here, no step zeros. So always start on step 1. Let's look at another example. Let's do 3, 6, 12, 24, 48. I'll just stop for good. So our next sequence is down here. And Alyssa, what is the pattern happening with this one?
Threes.
3s. What about the 3s?
They're all being like they all can go into 3.
They're all definitely all into 3. But when I ask for the pattern, I'm kind of looking for how could I get to one step to the next step? But that is a true observation. All of them are divisible by 3.
3 times something.
Good. 3 times something. Eliana, can you finish it off? What are we multiplying each time?
I don't know if this is it, but I did like it's
3 times 3 and then 6 times 6 and 12 times 12.
I think you're saying 3 plus 3 gives you 6. 6 plus 6 gives you 12. 12 plus 12 gives you 24.
Yeah.
Yeah, that's fine. But when you add something to itself, it's the same thing as multiplying by 2. So here, what we're doing each time is multiplying by 2. Okay. 3, 6, 12, 14, 24, 48. Anyone want to go for the A6 here? The 6th step in the pattern?
Um, 96.
Good, 96. Okay. And then you could technically go on forever with this. So it's identifying the pattern and then applying said pattern to whatever step I tell you to. So I could tell you to A10, maybe I just tell you the next one, depending on the numbers. Save it. Oh, I never saved it. Ouch. To what chapter is this? 7. Okay. So this is if we have the pattern, we could just find what the pattern is and do the next one each time. What we're going to do now is given the equation of the pattern. These equations are just like functions. Just like functions, they should have the same variable.
Wait, can you go back for 1 second?
Sure. Any questions on it particularly, Alyssa?
No, I just
Okay.
need to copy it.
All right, just tell me when you're good.
Okay, I'm good. Thank you.
All right. So AN represents some formula to the nth power. And we kind of already talked about this. It's some nth term, so it's the 5th term, the 6th term, the 100th term of the sequence. All right. So it's going to give you some nth term. We want to find the first 6 terms for this sequence right here. So as we always start counting, it should always be A1, the first term, A2, A3, A4, A5, A6. So we need to find the first 6 terms. Haley, any guess what we're going to do with this 1 value in the equation?
I don't know.
All right, Ella, any guess?
No.
All right. Since this is an n over here, we see a of n became a of 1. That means every n over here should also become a 1. So here, we're going to have 2 times 1 plus 5, because I'm replacing the n's with the 1. So it's just like we've done before with normal equations. Instead, we always start at 1 and we count up to how many I tell you to. So 2 times 1 is 2, 2 plus 5. That overall equals 7, which means your first term is 7.
Mr. Toll, I have a question.
Go ahead, Moran.
So you're saying that every you have an A1, you just put the N as a 1 whenever it's just AN?
Yeah, whatever your A number is should be the N number. So they have to match. And then to bounce off that, if it's 1, you put in a 1. If it's 2, you put in a 2. So that's 9. 2 times 2 is 4. 4 plus 5 is 9. And you could do this for each one. I'm just going to complete it out. You guys also complete it out. So you guys do 4, 5, 6, okay? One, two, 1, 2, 3. Okay, let's see. Nahum, can you give me the last 3 terms here?
Sure. 13, 15, and 17.
Excellent. 13, 15, 17. And just like any sequence, they always follow a pattern. And you can see the pattern should be +2 each time.
Wait, so you know you're doing something off if it's not a pattern?
Yeah, if it doesn't follow a pattern each time, yeah, you're doing something off. Good call.
And it doesn't matter like what number the pattern is, as long as it's a pattern, right?
As long as the pattern's consistent, yeah.
Okay.
So this pattern, if I asked you what the pattern would be, it'll be +2 each time. Let's do another one. Our next one, I'll keep this up here so people can work on it. A of n equals 2 to the n minus 1 power. Now this is an exponent. So 2 to the n minus 1 power. And again, I want the first 6 terms. So we're going to find a of 1, a of 2, a of 3, a of 4, a of 5, a of 6. Okay, Google, when is it going to stop raining?
Saturday in Pompton Lakes, rain's expected until 9 a.m.
All right, no, Saturday. Okay, so here we have a of 1. The same concept applies. Even though it's in an exponent, we replace the n with a 1. So 2 to the 1 power minus 1. Everyone should.
Wait, Mr. Tobal,
Yeah,
I thought you were replacing the n with 1, so it's 2 times 1 minus 1, which would equal 1.
it's not times, it's to the power of. So 2 to the power of n minus 1. If I did it like that, it should look like this. If I did it like that, what you said, okay?
So it's just 1.
And then I think Ella said it's just 1 because 2 to the 0 power, anything to the 0 power is 1. So your first term is 1. Next one, 2 to the 2 minus 1, which is 2 to the 1 power. Anything to the 1 power is it's itself. So that's 2. 2 to the 3 power minus 1 is the same as 2 to the 2nd power. That's the same as 2 times 2, which is 4. Since I modeled the first 3, I would like you guys to finish the rest of them. You could use the pattern to the advantage. If you see the pattern, then you can use that to advantage to also fill it out. That's how I do it quickly. So I look at the pattern and I say, okay, this has got to be next.
Mr. Towal,
Yeah, what's up, Mariah?
I did something wrong.
Well, let's see. What do you do? Go ahead.
I was following the pattern, so I got 4, 6, 8, right? So then I thought it was +2, and then I
Mhm.
looked here, and then when I got A4, it equaled 8. So now I'm confused.
That means either A, your pattern is wrong, or B, your math is wrong. So try to figure out which one is wrong. One of them is wrong. I can tell you that for a fact.
Okay.
Let's see. As you work on that, Haley, can you give me the next 3? Or the last 3?
I'm kind of confused on how to do it. I don't really know.
All right. So there's 2 ways to do it. One is you could plug in the number into the equation. So 2, now the n becomes the 4 in this case, because it's 4. I clicked blue and for some reason it gave me green. Minus 1. So I'm getting A2 to the 4th power minus 1. 4 minus 1 is 3. And 2 to the 3rd power is 2 times 2 times 2, which is 8. So Haley, instead of giving me the next 2, what it would be the pattern here? What would be the pattern between 1, 2, 4, 8? What's happening each time?
Times 2.
Times 2. So your pattern's not +2, Mariah. It's times 2. So you do 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 gives you 16, and 16 times 2 equals 32. And if you were to do that out, you'll see the pattern also matches what we have here. This would be 16, and this would be 32. 2 to the 5 minus 1, and 2 to the 6 minus 1. So if you did it out the equation, you'll still get the answers. If you notice the pattern, and you have to notice the correct pattern, it will give you the equation. Okay. Let's go again with a harder version. We'll just crease it a little bit each time. Everyone has this down? Does anyone want me to stay on this page? Or needs me to stay on this page, I guess? Okay. Our next one, a to the n equals 3n minus 1 plus 2 plus 2. So everyone's trying this out. And I want everyone to get me the first 6 terms. Now the method you get it, I don't mind. If you see the pattern, make sure you do the pattern. If you don't see the pattern, you always just plug it in one at a time. Now, before you claim a pattern, make sure to get a couple down. So get at least 3 down before you claim the pattern. Because the pattern, if you see from one to the other, you might think, oh, it's just +1. Let's say I'm thinking of the last one, which is 1, 2, 4. Oh, it's just +1 if you only had 1 and 2. So you might have put 1, 2, 3, 4, 5, 6. And you would have got it wrong. So make sure you get a couple before you claim the pattern and you can confirm that pattern. It's okay if you don't see the pattern to the last one. Again, the question is just give me the first 6 terms, however you need it to get it. Okay. All right. I'm going to do the first one and then I'm going to pick randomly to give me the rest. Let's see. So if I were to do the first one, I would have to plug it in. 3, 1 minus 1 plus 2. That's 3 to the 1 power plus 2. Or I'm sorry, 3 to the 0 power plus 2. Anything to the 0 power is 1. So 1 plus 2 gives me 3. So my first term is 3. 2, 3, 4, 5. Yeah. Okay. Let's see. What have we got? Well, how many kids? 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6. Oh, we got 6 kids and we got 6 terms. Let's go. Nahim, what is the next term?
Okay, so I just corrected my math. The next number is 9.
9. Let's see. I agree with that. 9. Okay. Haley, do you have the third term?
No.
All right. You're going to have to say out loud how to do it. Go ahead.
Mr. Joel,
Yeah, what's up, Alice?
I thought for the 3 to the 1 minus 1, it would be 1 because like 3 to the 0.
Yeah, so this number becomes the 1.
Oh, and then
Plus 2 becomes 3. Yeah. All right. Haley, so you don't have term 3? Talk me through it. How do I get term 3?
3 to third minus 1 plus 2.
Good.
And then 3 minus 1 is 2. So 3 to the third power plus 2. 3 to the third is 9 plus 2 is 11.
11. Yeah, it's 11. Nahim, you got the second term wrong. That's why.
Guys,
Yeah, I thought wasn't
I
it
did.
5?
Yeah, you got it wrong. Go ahead.
Isn't it 5?
Is it 5? I'm just going to plug it in just to check.
It's 3 times 1. And then
Plus 2 would be 5. Yeah, should be 5. Good. And then this one should definitely be 9. Plus a little 2 is 11.
I got this one very wrong then.
That's fine. So Ella, can you give me the fourth one then?
Yeah, I have to do it.
Okay, speak it out. What do you got to do?
Just 29.
29? Good,
Yeah.
because you will get 3 to the third power, because 4 minus 1 is 3, plus 2, 27, plus 2, 29. Who's next on the camera? Alyssa, A5.
Well, I got 81 and then so 83.
83, good. And Eliana, you got the best for last, A6.
Wait 1 second.
Go ahead.
Okay, wait, 3 to the 6. Okay. 247. Oh, 245.
Good, good. 245, because 3/5 plus 2, so 240. Is that 243? What's 3 to the 5th power?
Plus 2. No, it's 45. You're doing plus 2. 3 times to the exponent 5 is 243. Plus 2 will give you.
Oh, okay. Thank you, thank you. Plus 2 gives me the 245. Thank you. So 245. Now, understandably, you look at this as like, Mr. Tobel, there's no pattern between this that's consistent. And let me just move my camera so I have a little bit more space. Okay. So 3, and I don't understand when it clicks. 3, 5, 11, 29, 83, 254, or 245. And honestly, yeah, it looks like there's no real pattern to it. Kind of like it gets bigger and bigger really fast, but what is the process of it? So let's talk about the pattern a little bit. This you wouldn't necessarily need to be able to do, but I just want to talk about the pattern a little bit because it caused something interesting. All right. So from here and here, I would say the difference between 3 and 5 is 2. The difference between 5 and 11 is 6. The difference between 11 and 29 is 18. The difference between 29 and 83 is 48. No, 40, sorry. 42. $52? 52, yeah. And then 83 and 245 should be 10. No. This is 24, that's 54. And then this right here is 162. There we go. All right. So the original terms here, you could kind of see there's no real pattern. It's like it doesn't look clear. Like, but the differences between them has a pattern. Good. So sometimes the pattern is not in the original, but the pattern is in the pattern itself. And that's what's kind of cool about sequences. That sometimes the pattern is in the pattern, or sometimes the pattern's in the pattern that's in the pattern. And sometimes it's something like that. So that's sometimes very interesting depending on what situation you guys are. Okay.
That's
All
so
right.
annoying.
Yeah, that is annoying. But again, you could always default to, that's a hard pattern to see. I wouldn't expect anybody here to see that pattern, especially the first time we're doing something like this. So there's no problem with not knowing that pattern. Because we don't know that pattern, that means, you know, we just have to do it one at a time. And there's nothing wrong with doing it one at a time.
On the test, you can make us do it like that, like all the way down, or you just can make us do like that part where it's like we find the pattern and like.
I'm not going to force you to do it either way, but if I gave you this question, like the safest bet is always do it all the way down.
Okay.
Yeah. But if you see the pattern, but you need to do at least like 3 of them before you could claim a pattern. So I know everyone will have to do at least 3. And then from there, you could, if you see the pattern, like the previous ones, you could probably see the patterns times 2 and then work from there. but
No, I'm saying, are you
Um,
gonna get to the problem where we won't see the pattern on the first try, and you're gonna have to make us go like down and then down?
I mean,
like to realize.
depending how much you want to practice this, like, would I expect you to see this pattern? No. Even after telling you, should I expect you to see this pattern? That'd be pretty difficult. At that point, trying to figure out the pattern takes longer than just plugging it in. So
That's what I was asking. You to do.
yeah. So unless the pattern is pretty easy, yeah, just do it normally. So we're gonna take this, we'll do our last problem to be an interesting one. All right. So we're gonna make a pyramid of apples, okay? So we're gonna make a pyramid of apples for like a grocery store. So we're gonna have our first apple right here. Actually, it should be red, right? So we're gonna have our first apple right here. Looks more like a cherry, but whatever. The second layer is gonna have to support that apple. So we need 4 apples around it. Kind of like a little pyramid. So we need those 4 apples. So on the top layer, it's 1. And on the second layer, we have 4 apples. So that's 4. The third layer, we're going to need 4 apples for each one. But some of the apples double up. And actually, you know what? There you go. Let me just get a little picture real quick, because this is going to be a little too hard to draw for me. A picture here, I have my main computer over there, but I can't copy and paste from here and here. So let me just go open this up. Page 495. There you go. I drag this picture. So we got big apples. So apparently they're Granny Smiths, they're not red apples, but whatever. So here we have the third layer, which means there's like 3 here, 3 here, 3 here, 3 here, plus the 1 in the middle. So we end up having 9 apples on that layer. We got our 4th layer. Seems like we have a 4 by 4. And then we'll have like a 4 in here. So that's 12 on the outside, 4 on the inside. So that's 16. So I'll give you the first 4 terms. This one would force you to use a pattern. I did not give you an equation for this. Try to figure out what is the pattern of these numbers. And then someone, if you privately message me the right answer for the 7th layer, so what would the 7th layer have? You're free to go early. If you don't get it right, I'll just explain a little bit and you go like 1 minute later. But if you think you can, tell me what the 7th term is. This would be A1, A2, A3, A4. So try to look at it and see if you can find the 7th term. And I won't tell if you're right until the time is up, which I'll give you a minute and a half. Okay, Google, put a timer for a minute and a half.
Okay, 1 minute and 30 seconds. And we're starting now.
What is going to be the 7th layer, that bottom layer of this pyramid of apples? What kind of shape is happening? Or what kind of pattern of numbers are this? Everyone try it out. Haley, is that for the 7th term?
Oh no, it's for the 5th. I didn't realize you wanted the 7th.
That's fine. Okay, Google, stop. All right, time's up. Ooh, Nahum, you would have made it too. Now, let me talk about this. The squares, these are squares. Now, literally, they are squares, right? The apples actually form squares. But the numbers are also squares. And that's kind of cool. At least I think it's cool. 1 squared, 2
Oh, I
squared,
didn't catch
3
that.
squared, 4 squared. Which means this A7 should be 7 squared or 49. Now, since Nahum didn't catch that, I imagine what you realize is the pattern is +3, +5,
Yeah.
+7, good, and then +9, and then you kept going from there. So I don't know, I just want you to share this. It's cool because the actual apples form a square, but the values are squares too. Even in this pyramid, which you think about triangles, it's actually a square pyramid because the base is a square. All right, that's the end of the cool part of it. You guys, if you type here for your attendance, and then you're free to go afterwards. Have a wonderful day, okay?